Thank you very much, Anki. I really appreciate it. And thank you so much for everyone for coming today. It's always great to see you guys supporting the Google I/O Extended events. I know I learn a lot and I meet a lot of really cool people at these events. But let's jump straight into it. So today I'm going to be introducing a new product called Citation. So Citation is a piece of automated report generation software. I've been in the software industry for like 3 decades now. I've also spent a bit of time in the civil engineering world, and what I've realized in personal experience is that engineering is facing an avalanche of paperwork. Tenders, reports, compliance, the government makes you fill out massive piles of forms for just about everything you build these days. And the crazy thing is that although we're using very sophisticated computers that would be considered supercomputers by any of our predecessors, like my phone has more computing power than any computer would have had 20 years ago, we're doing so much of this work manually, particularly when it comes to the engineering world. In some cases, it's so bad that engineers would actually be better off using pen and paper, ironically, despite all the incredible technology they have available to them. We've noticed that some engineers, and these people are our clients, they're spending as much as 30% of their time generating reports, which is a lot of time to be doing paperwork. And it's really not fun. It's not enjoyable. I speak from personal experience, having written many tenders, requests for comments, those kind of things. And it's actually really bad for morale. So what tends to happen is in an engineering company, the young guys that are just starting out get lumped with this work because nobody else wants to do it. But then that's actually bad because it increases your turnover. And the first thing these people experience in their career is a very drudgy, dreary sort of work that nobody likes. But we have a solution, and we're going to leverage data and the Gemini AI to solve these problems. And you're going to notice I actually gave a talk about Gemini recently, and I've done a bit of an upgrade. At the prompting of my wife, as it turns out, she said it's not Gemini, it's Gemini. So I'm going to try and say Gemini because that seems to be what everyone's standardizing on. So bottom line is our goal is to save time and improve consistency by automating report creation. So our whole concept with the Citation project, the way we started off was we approached an engineering company, or more accurately, they approached us. And they said, look, our engineers are spending a huge amount of time writing these reports. We've seen there's all this new technology that's available. Can you help us to cut down on the amount of time that they're spending? Because it's very repetitive work. So our principle in this project was days to minutes. And we used Gemini to accomplish this. And I'm going to be showing you that a little bit later. But I was just wondering, can anyone stick their hands up if they had a chance to look at one of those printed out reports that I passed around earlier? Okay, so most people looked at it. This is the first time I've given a talk where I've given people a physical thing to show them, which I think is really cool and really, really different. So if you haven't seen it, please, I've passed a few of them around. That entire report was written by Gemini. That's what's really, really amazing about that piece of paper you're holding in your hands, including all of the imagery. The only thing inside that report that wasn't done by Gemini is the little markers and annotations that I drew on the maps. But that only took me a couple of minutes. And that's not something that you want Gemini to do because that's the final analysis step. That's where the engineer actually says, hey, there's this and there's that. And because of that, you need a bigger sewer line or something like that. So our technology is a report automation tool. It probably doesn't sound super exciting. But if you understand that the average engineering report that we're automating costs $10,000 to buy one of these reports, and that an engineer has to spend several days writing a report, basically effectively 100% manually, I'm sure you can see there's a lot of fat there. There's a lot of time and money savings that can potentially be made, which is good for everybody in that chain. $10,000 for a piece of paper that's 30 pages long is a lot. A lot of people can't even afford that, even if they wanted to get it. So right now, these kind of reports are actually pretty exclusive. Really, only very high-end developers can afford them, which actually hinders our economy and our building in many ways. You often hear people talking about, oh, there's a housing crisis in Australia. But what people don't realize is, let's say your grandfather gives you a block of land, right? And you want to build a house on it. The first thing you do isn't to call your builder and say, cool, bring your bricks and your hammers, let's go. You've got to get approvals, you've got to get council building approvals, you've got to get all kinds of paperwork done. And in order to do that, you need reports. Because you don't know, do you need to install a new water line? You don't know any of that stuff. Your builder doesn't either. He's going to hire someone who's very, very expensive to do this. And our whole process here is to replace this tedious report writing workflow. That's what we're focusing on. And we're doing it by using an AI reasoning engine, which we've developed ourselves. And the beautiful thing is, the entire thing exports to a Microsoft Word document, which I printed out and I handed out to you guys to look at today, which means that the final product is completely plastic and editable, and you can do whatever you want with it. You can delete things, you can tidy it up, do whatever you need to. So let's talk a little bit about how citation works. We've created what we call a template-based workflow, because the current workflow in most engineering companies is this. You sit down at your desk and your boss comes to you and says, I need you to write a report. It needs to be the same format as that other report we did last month. And typically, they email you a Microsoft Word file as an attachment in an email, and then you take that and you strip out all the bits from the last project, and then you start writing a new report. That's the gold standard in the industry today, believe it or not. And people pay a lot of money for this, and it's actually ridiculous because, no offense to Microsoft Word, but it's the most terrible report writing tool imaginable. It's not designed for writing reports. Microsoft Word is a piece of desktop publishing software. Totally different thing. So what we provide with Citation is an intelligent integration of ArcGIS, which is mapping software that almost all of you have used without even realizing it. It's basically the second competitor to Google Maps. It's just a little bit smaller than Google Maps. Google Street View, which everybody knows and loves, and local council and state government data, of which there's a huge amount of public data for things like where are the water lines, where are the stormwater pits, all that stuff. You'd be amazed how much of that stuff is publicly available, but it's not easy to get to. You have to know where to go, you have to know what to look at, which layers to do. It's not a very simple process. You'd really need an engineering background to do it. But what we've done is we create polished professional reports by using Gemini, to integrate all of those things for you. It's a very repetitive process. There's absolutely no reason any person in 2025 should be doing this stuff manually. There is zero reason. It's actually, you're just wasting your time. It's a bit like riding a horse down the M1 motorway. You probably shouldn't be doing that. I mean, you could, but you probably shouldn't be. There's laws about it. So I'm actually going to dive into a demo of the software in a couple of minutes, but I just wanted to talk about what you can do with it. What kind of content can you actually put into this Gemini-driven reasoning engine and get a report out on the other side? So the most obvious one is things like section headers, and another really obvious one is AI text. So it might seem like this is just, a wrapper around an LLM, but it's not. There's actually way, way, way more to it than that, and that's why we realized when we start to build it, you need much, much more than that. So that's why we built the reasoning engine. You can also have boilerplate text, because you don't necessarily always want a large language model involved in your text. Sometimes you need legal text that needs to be 100% precise, cannot deviate from it. That's when you have the boilerplate text. One of the most important pieces of content you can have, though, is these map blocks, the ArcGIS maps. They're filled with very, very rich information, and you can make queries on them as well, like saying, give me all the water lines within this area. That's really the driving force behind this citation software, is that wonderful, rich data that you can get. And there's a huge amount of it available. You'd be surprised how much is available. Engineers use this stuff all the time, but it's a pretty exclusive coterie of people who typically are able to access it, even though it's public, which is crazy to me. You also have your typical Google Street View, which these days is a very, very commonly used tool in the engineering world because it's always up to date, it's very, very detailed, etc. Finally, you can have image files from any other software you like. Maybe you use something like QGIS to do elevations. You can just drag and drop those images into our software. And very soon, we're also going to be able to have table blocks, which means you can drag and drop a spreadsheet. Because that's what a lot of these engineering types do, is they're dragging and dropping heaps of tables, lots and lots of different tables of elevations, all kinds of things like that. That's one of our biggest feature requests. So I want to talk a little bit more about what we mean when we say intelligent automation. This is a very, very important concept that we've been absolutely grinding on this to make it work right. Because it's not just, when you're writing an engineering report, you're not just putting a prompt in and getting an output. There's way more involved than that. You have to synthesize many, many different types of information. You have to look at a map, then you look at the street view for what's currently ground condition, then you look at the assets, what does the urban utilities say is actually there under the ground. You have to synthesize all these kinds of information to reach a conclusion. We have automated that, and we call that process intelligent automation. We allow Gemini Vision to do a lot of that heavy lifting for you, and the only thing you have to do is type in a new address and repeat that same process for different properties all over the place, as long as there's data available. And I just want to say, this automatic retrieval of data and this automation is way more complex to create than you would think. It was actually one of the biggest parts of running the software is all the under the hood, behind the scenes stuff that just makes that beautiful report pop out. There's way more to it than you think. And I'm going to cover the development aspect a little bit later as well. But in a nutshell, you can have multiple types of data like visual data and table data and text data and even legislation and urban utilities assets all being integrated and synthesized by Gemini AI. That's where the vision stuff really comes in. It helps in that process, and it helps to recognize objects, classify objects, and so on. I'm not going to spend too long on this because I don't have a lot of time today, but sometimes we show our clients, and we had some very tough clients that we showed this to, and they said, oh, well, I've used ChatGPT and stuff, and the output it's not great. It's pretty wishy-washy. It hallucinates a lot. We don't trust it. This is the big problem that people deal with today with LLMs. We don't trust it. We're not sure. We know we're engineers. We have to get this stuff right. People are paying us a lot of money to get this stuff right. So what we worked with is we told them, well, actually, modern technology allows us to reason at what I call a PhD level. A place where the formulas are so complex that I almost need a maths teacher to explain them to me. The LLMs are actually really, really good at this as long as you know how to use them correctly and as long as you hook them up to enough context information. And that's what we've done with our reasoning engine. So what I've got up here and over here is an example of one that was a problem posed to us by a traffic engineer. They solve this problem all the time when they're writing reports, because this is what their reports are all about, is these complicated formulas. They have to look at legislation. There's laws about certain things that they have to incorporate. And that's the output from it. And we show that to them because they gave us a problem and they were like, oh no, we don't think that your chat thing is gonna solve this, Derek. And they gave us the problem and we said, well, if you give it the right information and you use the right model, it actually can do that. But it's all about how you engineer your prompt. So they were very impressed by that. I don't know if everyone can actually see that on the screen, but the important part is the last part there, where it's working out the formula. And they really loved that it shows the working as well, so they can actually double check that. They wouldn't necessarily include that in their final report, but they need to verify those steps before they hand that to their client. That's super, super important. But now they're just doing paint by numbers. They already know all the formulas. They've done this 100 times. They don't want to do it again. They just want to punch in the relevant numbers and values and get something out, check it, and keep moving. That's a much, much nicer workflow for them. And we've been able to achieve this using Gemini AI. All right, guys, this is the part everyone's been waiting for. I do want to stress the real demo here isn't me showing you the software running, although it is very cool software. The real demo is that piece of paper everyone's been holding in their hands today. That's the real demo. It's the first time I've ever given someone a piece of paper as my presentation. But that's what people, they're submitting that to governments, they're giving that to their own customers. That's the real demo here. That's the level we're able to reach with this new technology. I find it incredible. A report like that would take someone days to write normally. Now they can look at that, make a few adjustments, and it's done. That's what I'm going to be showing you today. But let's get into the software. That's what everyone is here for. So Citation is a web application. I'll talk about the architecture in the stack a bit later. You start off with a template. So the biggest problem a lot of these engineering and many other companies running reports face is their actual workflow sucks. When you're just like copying a Word document, and then you're replacing some bits, that's actually a really awful workflow for creating consistent, high-quality reports. It's possibly the worst workflow. You'd actually honestly be better off just writing it by hand because that process introduces problems. One of the biggest problems it introduces is inconsistency and missing things and accidentally including that super sensitive piece of data that you don't want anybody to see. That's only 3, and there's many more other problems as well. The other main issue is that you don't really know what you need to bring with into the new report. So we have the template system that solves all of that. An administrator or a high level, perhaps a senior engineer, creates a template from an existing Word document. And I'm not actually going to take you through the template creation process. Happy to show it to you if you want me to show it to you later because it takes a bit of time. But in a nutshell, we take the Word document and we just create sections for the paragraphs, the map images, and so on. And I'll show you what that looks like. So I've created a report just a little bit earlier from one of these templates, and this is what it looks like. Hopefully everyone can see that. So much like Microsoft Word, which is the structure of this is all based on the left here you've got an outline view. The main action happens in the center here though. Everything you're seeing here has been generated by the AI. So I've literally just gone in and typed in a new address earlier and I said, create a new report for me based on this address. And it's gone off, it's grabbed all of the map imagery, it's grabbed all of the street view imagery, and it's taken all that, and once it's got all that ready, it then created this report for me. So let's look at a little bit more of a chunky section over here. So you can see I've got all these different blocks, right? So there's a lot going on here, and I can't spend too much time on it, but in a nutshell, it's taken that address I've put in and it's gone and actually asked ArcGIS, first of all, give me a high quality map image, then tell me what all the water and the sewer and the other assets are, and it's created a database and a context that my reasoning engine can then use subsequently to generate text using prompts. So that's where the synthesis concept comes in. You have to have the map image first and you need the data first before you can then do your actual engineering job, which is to look at that and say, are these guys going to have to spend $25,000 to install a water main or not? That's a critical decision many people make in these kinds of development projects. And you really need an expert to tell you that, because if you make a mistake, you are going to be in a world of hurt. That's why people spend so much money on these reports. But the beautiful thing is that this isn't like something you need to be an Einstein to do. You really just have to look at a few different bits and pieces of data and have a reasonable background knowledge. Most of that can be automated, as long as you've got the right data. So you can see here, I'm showing you the final result. It's giving a report as to whether, you know what assets are currently there. This is typically stuff people are spending hours cutting and pasting out of ArcGIS. That's the typical workflow here. That's already done. You just have to look at it and say, oh, it's not quite what I want. Oh, I don't need that bit. Oh, what about this? But notice here, the technology we're presenting to you today, it's not perfect. We have to be real about that. Our goal is to automate 80% of the report writing process. That's why down here, I've put in a little placeholder to say, the engineer is to report whether the site is currently vacant or occupied. There's no way that Gemini can know that. It's simply not possible. That's something you actually need to pick up the phone and ask somebody about. You have to call a real estate agent. So we have to be realistic, and we're aiming for an 80% coverage of what's in that report. That's what's key to us. But that 80% is the work that sucks, that nobody wants to do. Engineers really don't mind doing the last 20% because that's when they have to analyze data, make decisions. That's no problem. They love doing that. So down here we've got another different kind of section. Once again, it's been automatically placed in there for me. This is the Street View section. So every one of these, we call them blocks, they're live. And when I say live, I mean live. Like this is literally a Street View bubble that I can navigate. And we've got another new feature in here as well. So you've probably never seen all those blue things before. Those are assets from Urban Utilities, because Urban Utilities has all these maps, and every council in Australia does this, all over the world as well. They have these maps with latitudes and longitudes of where every single thing is on your street. Your sewers, your main, your water lines, all of that stuff. We're the first company that's ever projected these into a Google Street View panorama. And the beautiful thing about that is that I can then go in and just pick the ones that I actually need. So let's say I'm interested maybe in the, Let's say I'm interested in just having one or two of the assets here. I'm just going to turn them on again. Sorry, just bear with me. This is a little bit tricky to do when you're over here. I just want to find the one that I want. Sorry. You can see there's a lot. I'm just going to see if I can turn some of these on. Okay, we won't dawdle on that, but in a nutshell, you're able to project these assets in here, and then you click Save. So normally you actually have to go through and pick, you're just normally interested in one or two, but then I can come in here, and I can annotate this image. So all of these shapes, I just popped them in here before, so we have a complete engine where you can do arrows, this is one of the most important things that the engineers do, is they're annotating the image, they're saying, here's your fire hydrant, is it enough for what you want to do, all of that stuff. Then they click Save. But what's really interesting is once I've saved that annotated image, which is one of the most common things in these reports, I'm then able to do a prompt on it, and the prompt is actually able to pick up all of my annotations that I've made and intelligently use that information to create further parts of the report. So I might annotate some of the water features in the first part of my report, but later on my report is actually going to summarize that, saying because you have these water features, you will not need to install a $25,000 main water line, or you will need to install it. So these are the kind of opinions people pay a lot of money for. But the amazing thing is a lot of that can be automated just by an engineer going through and marking up a few things, because they're the experts, they know what to look for. That's what really matters. They don't want to be sitting there copying and pasting stuff. So I'm going to show you the prompt I used to create this. Hopefully everybody can see that. That's the prompt. So this is the power of Gemini AI. This is what it can do. When you integrate it with a reasoning engine, you've got multiple sources of data, multimodal data being synthesized. You're able to put all of that together into a single tiny English language prompt and get that kind of output from it. That's an absolute game changer for people who write a lot of reports all day long. They just write a little report. You can be as specific as you want. You just have to give it very specific instructions, and this is the kind of output that you get. All you do is you click the generate button. And up here too, we can edit these very easily. So let's say I want to, just for a demo, include a small poem about engineers. So you can customize these things from your template as much as you want. You've got total control, right? It's as simple as that. But the beautiful thing is, because it's derived from a template, you don't have to worry about destroying the original template. It's just a clone. You can then create your subsequent reports without worrying about, have I destroyed my original? It's all just a clone. So it's a really, really nice process. But I haven't even shown you guys the best part yet. All of this is automatically generated. So what's the final thing you do? You press the big Export to Word button. And now I've got my document sitting there. It's instantly created. It's created a 7.3 megabyte Word document for me with all of that imagery built into it. So let's open that and see what it looks like. There it is. So I got my report. So the important thing to remember here is I've taken an existing report document and I've just used that basically as the basis for this export. It's synthesized all that data. It's popped it all in there for me. It's written all of the sections, all based on a few prompts. Remember, there's that little poem? So this is all just based on a few carefully written prompts. You don't have to do a huge amount of work because Gemini is doing a lot of the heavy lifting for you. It's going off. I had to add a few annotations to the map, but that only takes a couple of minutes. That's easy. But here comes all of that data. This is the real meat of the report, all of this stuff here. This is what people are paying money for. That's the key here. We've eliminated so much of that manual work just by having the power of these reasoning models and our reasoning engine to achieve that for us. But I can come in here and, if I don't like this row, I can just delete it. I've got full control. This is a Word document. I can send it to my boss for him to check, whatever. It's exactly the same, but we've just cut out that 80% of the tedious work, and now they've got all this ready to go. They can just edit it and tweak it a little bit, maybe add a bit of that and that, and they're very happy. That's just a huge improvement to their workflow. So that's a very, very brief demo. There's way more to the software. We're introducing the tables and spreadsheets soon as a new source of multimodal data because LLMs love tabular data. They're great at interpreting it. So then all of the water engineers are going to be over the moon because they spend all day looking at boring spreadsheets. It's not much fun. They'd much rather have that automated for them as well because a lot of times it's just looking at a few columns and saying, oh, because this one's over 20, you have to worry about a 1 in 500 flood risk. Things like that are things LLMs are absolutely capable of doing and automating as well. So now I want to get into the actual part of this talk that's relevant to this audience, which is a Google Developer Group audience, how we build citation. So I wanted to dive a little bit more into it. I only sort of showed you guys, the tip of the iceberg of how it works. Our backend is Python. We have a Python API. We use AWS microservices and an RDS database. These are very, very standard, straightforward things. And the reason we chose that was just to allow us to scale. So we want to be able to support 100 customers or 100,000 customers equally well. Microservices is really good for that. Our front end is written with React. And the joke in our office is that I still don't know React, even though I've written this whole thing in React. But that's the wonderful thing with all of these powerful tools that we have available now is you don't have to know everything about a language or a framework to be able to use it, as long as you're able to carefully look at it and create your unit tests and have acceptance criteria, you can make it work. You don't have to spend years learning things anymore. You can just roll things out, make sure that they work correctly, and off you go. You're off to the races. I love that about it. But yeah, that little picture there is a live video of me using React most of the time. Very complex. I would argue that React is an AI-only language. That's my opinion. It's so complex that you cannot actually understand it as a human being. And I speak as someone who's written software for 30 years, so I'm not exaggerating here. But the amazing thing is you don't have to anymore. You can be productive and get things shipped without particularly needing to worry about that. Obviously, we use Google Maps, we use ArcGIS, so we actually have a great relationship with Esri. We're a member of their partner network. They're powering a lot of the underlying data that comes into citation and goes into the reasoning engine. So basically, every council in Australia uses Esri software. It's the lingua franca, you might say, of engineering and GIS. We created a massive background preloading engine. All that pretty stuff you saw, that all gets loaded in the background. It's actually a crazy complex process. You have to do lots of automation and asynchronous loading. And the crazy thing is that JavaScript isn't an inherently asynchronous language. It has one event loop, that's it. The fact that we're actually able to do this in a browser is incredible. I was even surprised myself. Normally you have in multi-threaded languages, you have lots and lots of threads doing things. You don't actually have that in JavaScript. So you have to have a totally different way of thinking about how you do background processes. And that was one of the challenges that we had to solve. That's why our reasoning engine has such a complex architecture. But the beautiful thing is the user doesn't see that. They don't see that we have 6 different kinds of caches because LLMs are thousands of milliseconds before they give you a response. They don't see that. They just see pretty pictures. So it takes a lot of very careful code to write something like that. I mentioned Esri already. Other thing I've mentioned is to build an app like this, you do need significant knowledge of GIS. But what we're doing with Citation is we built it initially for engineering people, but we've tried to build it in a modular way so that you don't necessarily need to use the maps. That's not compulsory. The reasoning engine can be just used with tables or just with text. It's entirely up to the user how they want to do that. For example, you might want to do a real estate valuation report. You don't need urban utilities assets for that. The reasoning engine will work just fine, and we've designed it to be generic and work well in that case too. Just wanted to, I've already kind of covered these before, but we have put in a couple of unique new features in Citation for anyone watching this that are, I believe, have never been available before at all. The most important one that I showed you was that projection of 2-dimensional flat ArcGIS map features into the 3D panorama bubble. That's something that the engineers used to do completely manually before. It was a very tedious, opening it in Street View, drawing a little thing, and then if you move the camera, everything goes to hell basically. Because we've projected them into that 3D panorama space, that's no longer an issue. That becomes a very, very smooth, easy, nice workflow. And the beautiful thing is the AI will pick up, the reasoning engine, it's going to pick up those assets that it sees in the images. It picks up the little assets that have been projected in 3D space. So you're basically making it a lot smarter just by doing that. We talked about the templated prompting system. It's amazing that you can just use a few prompts, and because of all that rich data, you can then type in any address and it will generate a completely different report based on what it sees on the ground at that address, based on what water lines are there. It's actually incredible watching it sort of unfurl and be able to do that, but that makes you realize just how much training has gone into those Gemini AI models to enable that process. But at the same time, you have to give it the right data. The multimodal models is important. A lot of the heavy lifting here is actually done by the vision models, not by the text models, because engineering work and reports like this are heavily visual things. They don't really do, there's a lot of text, but the visual part is probably the most important. That was where we had to do a lot of the very difficult code to get that to work. We talked about the instant word export. People hate waiting around. It's one of the most classic things in web design. If you give them something that's instant, they're going to love that. People love that convenience. And they love the convenience of having an editable product too. We found that users will require a little bit of prompt engineering and a little bit of training to use these new products, because most people, especially in the engineering world, are not born prompt engineers. They do need a little bit of training. You need to show them the basics of this is how you actually prompt, this is how you get the results you want. Sometimes you have to use negative reinforcement, positive reinforcement, things like that. It doesn't take long to teach them, and we found that our clients actually really like it because they want to be involved. They see the promise of the tech, but they just don't see how it can work for them yet. So this is actually not a bad thing at all, but something to bear in mind if you write something like this, you're going to have to spend some time training your customers on how to use it as well. But that's pretty true for any new technology, really, isn't it? So it's really important to work with your clients closely on this new tech. That's the bottom line I'm trying to make here. Finally, a lot of people ask us like, oh, how are you handling your security? Is your AI model being trained on my highly sensitive engineering reports that if it gets into the news, there's going to be massive drama for my company? What's going to happen there? People are worried about this aspect when they use software like this. So it's very important that in our software to understand that users cannot see each other's data. So the way I describe our architecture of how we've put together all of our cloud systems is we've used the same principle as OneDrive or SharePoint. So you cannot see my data in OneDrive and I cannot see yours unless you share it with me. It has to be a deliberate action. So everything is very carefully secured in a very similar way to how you would do it in OneDrive or SharePoint, which are technologies people are obviously very comfortable with already. We use the same security model. We're going to be aiming for SOC 2 certification. So SOC 2 is like a specific thing that makes people comfortable with how we're dealing with their data. It's a set of rules for data security that a lot of very big companies follow by default. They won't even use your software if you're not SOC 2 compliant. And we're also going to get ISO 27001 and 42001. So 42001 is an interesting one. It's a new AI management system standard. So you're going to start to see more and more of this ISO 42001. Companies are going to start asking you for it if you're delivering software for them. They're going to be like, are you guys compliant with that? Because people love standards. They like to see that someone's got a standard. This is really, really important. Don't forget about this stuff if you're delivering AI software in 2025. Very well worth looking into. That's me done. Thank you so much for your time. Does anyone have any questions? Anything they want to know? You were first, sir.
Do you see this translating to other domains, say IT, OT engineering, and taking, say, vector drawings for a refinery and images and mapping those things together?
Absolutely, yeah. We've designed it to be as modular as possible. So in reality, it just works on images and text. Everything can be translated into those two formats. So we happen to start with maps and with Street View, but those ultimately just boil down into images. The reasoning engine is very, very flexible. So we've designed it to be very much able to deal with those. And one of our new features we're doing in the next few weeks is the ability to drag and drop a PDF, and it automatically becomes an appendix, but then it also reads all the images out and pushes them into the context. Then you can query against those. Yeah, so the short answer is yes, absolutely. Yeah. Sorry, we had one more question over there, sir?
Yeah, I just wondered, is it just as useful for junior engineers and senior? Because I can imagine if I'm a senior engineer and I've done these for 20 years, I can pick this up and I kind of know what I know and that. If I'm a junior engineer and I haven't done many of these, like, are they able to do it or do they need help?
It's a good question. I would say that one of the biggest problems facing the junior engineers is they don't know where to start. You give them a document and they don't really know where to go. But with our template system, at least they have a nice framework that's pretty much set in stone. It needs this section, it needs that section. At least they have a great starting point. At the same time, don't exclude the important, it's not going to do everything for you. That's absolutely the case. But it does give you that structure, and then a senior engineer can come along and say, well, you've done the auto-generated report, but did you remember that thing? You have to look at this thing. But the whole process just becomes a lot easier. I know when I started out in the engineering world, I was just sent a few documents in an email. And it's like, yeah, you take these and make us a new one. That was the workflow. And that's a crazily horrible, bad workflow. But at least here you have something that is proven that people have used before that goes out and knows how to fetch the data. Because half the problem is just knowing where to look. You know, you're like, oh, give me the link to that site. Oh, and you're wasting time. This one at least gives you a much faster starting point is how I would describe it. But you're still going to need the knowledge and approval, and we're going to have a sort of an approval workflow where a junior person can do a bunch of the work, then they can assign it to a senior person for verification. I mean, that's what we do as software engineers. That's why we have pull requests. The senior dev looks over your code, makes sure that it's not sus, that you've done all your unit tests. It's going to be a very similar workflow ultimately in citation.